Hello, everyone. Welcome to our first HiveMind Summit, which is a conference run by AI Product Hive. So we are a Slack community that is closing on 2,000 people, consists mostly of technical professionals who are interested in AI. So product managers, project managers, developers, designers, and many other cool people who are willing to learn more about AI. And yeah, we are collaborating and figuring things out together there on Slack. So if you want to join us, please go to aiproducthive.com and click the link to join our community. So if you like this format of short, focused calls revolving around different topics, mostly technical, of course, then please check out our playlist on YouTube. And if you will find it interesting, we are running those calls on a regular basis. So yeah, you can join for the future calls that will happen in some time. Please bear in mind that the call is recorded, and if you don't want to talk, please keep yourself muted on Zoom. And this is our agenda for today. So Matt will tell us about. Um, I'm not sharing the screen. That's strange. 1 second. I'll reshare the screen. So have you seen the screen at all?
Now we do. Now we see it.
Oh, that's
That's
cool.
okay. I don't
Yeah.
mind seeing. That's
Okay,
okay.
so yeah, Hiveman Summit. Please join us at producthive.com. Please keep yourself muted, and this is our agenda for today. So Matt will guide us through the case of sovereign AI in product development, and Sandi will tell us about BeeAI, which is IBM's open source framework for building collaborative multi-agent AI systems. So we are really waiting for that, and we'll kick off the meeting with Matt. So Matt is a co-founder and CPO at FlashQuery and founder and CEO at Planorama, founder of our community AI Product Hive, and has nearly 30 years of engineering career across hardware and software product development, from requirements to test and deployment. So yeah, Matt, please take the stage, and yeah, let's kick off the call.
Alrighty, let's do it. Can you all hear me okay? See my screen and everything?
Yep.
All right. So today we're going to be talking about, I'll say, the case for sovereign AI in product development. And this isn't about enterprise AI in general. I'm focused on product builders, and we're going to be talking a bit about FlashQuery, which is up here in the top left corner, which is a middleware designed to give control back to software teams. The talk is about sovereignty at the product level and not training your own models. So, AI sovereignty, not just for nations. If you've seen it, you may have just recently, it came out a few days ago that Switzerland, wants to control their own AI infrastructure. And the question is, well, why is that? Well, I think it comes down to they want to establish a trust, a security, an alignment for their own nation, for their own culture, what they value in and of themselves, and certainly to have some kind of, control and maybe not so much reliance on other countries. And it turns out that I think enterprise companies have the same issue. Um, there's a parallel challenge, right? There's a companies, if they're building software, they have their own data. It's very valuable. They have promises and policies that they have to adhere to for their own customers. If they're building software, they need to adhere to these performance and metrics that they are entrusted with for their customers. And also, there is a certain level of risk tolerance that comes with AI, and they need to mirror that. They need to handle that in some way that will allow them to deliver what they say they're going to for their own customers, for their own software users. So at the end of the day, if you don't control how your product uses AI, then it's somebody else might, right? And that's a real challenge. So I think this concept of how nations are looking at AI I think it filters down to how enterprises might be looking at AI themselves. They need to gain some control over this. So, so what does that mean? Well, if I'm going to talk about sovereign AI integration, I would say that it involves a couple things. Data boundaries, your data, your permissions, your users, your security, that all is going to play a part because it is, at the end of the day, it's retaining data within your infrastructure. You have to define what is allowed to go out and what needs to remain inside, right? Um, I'll say that it's also, from an accuracy standpoint, from a performance standpoint, you have to be able to define what good looks like and where data comes from that is used in AI responses. As you probably know, AI is more of a non-deterministic model that we have to deal with. So when you're going to define what does good look like or good enough, you're never going to be completely right. You're never going to be completely wrong. Sometimes it's somewhere in the middle, and you need to be able to define what you're comfortable with and what kind of risk you can take. And in fact, speaking of risk, then you also have to align AI with your policies, your controls, your GRC. AI must reflect the behavior and compliance and risk posture that is required for your software. So, Flash Query, I'll do a quick review of what this is. What we're trying to do here is enable AI sovereignty in the product stack. So, first of all, it runs in your own environment. It runs as a middleware that's containerized, runs an on-premise, can be virtual private cloud, whatever it is. You're running that locally. It keeps all the inference, all the data access, everything related to the AI subsystem, keeps it in your power, in your area, in your infrastructure. From the other thing I'll talk about a little bit, and you'll see it later on, is having a confidence in the responses that are coming back from generative AI. They are, non-deterministic stochastic models. We do have to care about where data came from that are generated as part of responses. We even need to be able to quantify some kind of confidence in what is coming back from every response and to handle that behavior in a graceful way. And finally, we do need to be able to consider from a policy standpoint, what are we going to be comfortable with when we use an AI subsystem in our existing enterprise application, and how are we going to track what happened over the time and of usage in production. So if somebody comes back and complains about some results that were coming back, you need to have enough logging and transparency within the whole AI subsystem to give you an idea of what happened and to trace that and to audit it and ensure that that even your monitoring as you move forward in your deployment is giving you feedback over time about how the AI is working. So Flash Query in and of itself, again, is a middleware that we created. It takes you from what I would say is the proof of capability. And I know POC usually means proof of concept. But I like to think of POC when it comes to generative AI as proof of capability, because we are trying to figure out, will AI actually help me solve a problem or maybe many problems in my software that were not solvable before. But that takes creating POCs, that takes experimentation. We're often doing that at the prompt level these days. So, and many times just getting to a POC, just getting to that proof takes some time to assemble. And so Flash Query, we built that with the idea that we could accelerate getting to a POC and to have, language models, whether they're external or self-hosted, all be accessible from within Flash Query, and also to give you the traceability and the debug capability as you're going through this whole POC process. And then finally, when you get to production, Flash Query is built from the ground up to be a secure container that uses user permissions, user data access rules that come from your own environment. So if you're doing SSO, that passes through Flash Query. all of those users, if they have access to certain data out, in the application environment, they will have access to it in Flash Query. If they do not, then they will not have access to it. And so to translate all of that through is very important, just from a ground level security point of view. And your data, all of your data can still pass through. Again, and if you are doing this in such a way that you have a concern about what goes out to certain language models that are outside of your environment, you can retain a lot of control just by having Flash Query be the center point of all the communication from your enterprise solution to the through this AI subsystem out to the language model. If you can control it all in your own infrastructure. Um, what we'll be doing today, and I'll show you a quick demo. I'm trying to get through these slides a little quick because I don't want to bore you with a lot of slides, but I want to give you an idea of where we're coming from today. So right now we have a POC set up, and I'm going to switch over to that shortly. Flash Query is running in a container on our own subsystem, on our own cloud. We have a few pieces of data coming in. We have electric vehicle data coming in, and we have electric vehicle spec sheets. And the data coming in is related to the vehicles themselves and what kind of vehicles they are. And this is data coming actually from Seattle, Washington, all about the ownership of electric vehicles. And it's available on data.gov. So we use that. There's no proprietary data here that I'm showing you. And Flash Query, we're going to be using the web interface as if you were doing a POC. And you could use it right now to go and test a variety of capabilities and ensure that you can get to the data that you need that we're providing here, right? The electric vehicle ownership data, electric vehicle spec sheets. And then finally, we're going to be using a couple different language models. We have two of them from IBM. One of them is the IBM Granite 3.38 billion parameter model that we're running on our own hardware, as well as the IBM Granite Guardian model, which is a really useful model. I'll talk about that in a little while, but we use that as well. We have fallback LLMs that are running externally. Of course, if they're OpenAI, we're using GPT-4.1 Mini and 4.0, and I'll show you what fallback means in our context in a moment. And finally, we're using Grafana here as a way to trace what is actually happening within Flash Query. So with that said, and I guess as a reminder, everything's running on our infrastructure, of course, except for OpenAI. We don't have that kind of money. So let's see it in action. I'm going to switch over now. One moment here. Let me make sure everything's all set. Yep. Okay. So I switched over to Flash Query. This is a web app, again, running in a container on our infrastructure. Let's just, for the sake of argument, let's just assume and play through a demo here that assuming I'm an AI engineer or product manager at a company called Cogni. The company doesn't exist, but let's just pretend it does. And so they create software for retail, petroleum, and electrical vehicle customers. So we've installed Flash Query on a container in our own private cloud so we can begin some testing of AI capabilities. I just logged into Flash Query, and I'm not going to show you the login process, but I logged in through my Google account. So I logged in through SSO already. And at the top, you'll even see we have Cogni Fueling right here. This is because we're working at the global level, but that means that we're operating across the entire SaaS suite of applications that we have at Cogni. So while I'm not going to be showing it here, I can drill down into every individual application and can make configurations at an application level. In fact, the way we have this set up, it can be at the global level, it can be at the application level. You can make changes and modifications. You can make configurations and manage users at the application, the tenant level, the user level. So we have a whole hierarchy built in here. And in fact, we anticipate that this is going to mirror the setup and the environment that you have in your enterprise application suite. So users that have access to certain applications and have certain configurations that come along with them will be passed through Flash Query here. So the first thing I'll do is I'll jump over to providers. So providers is where we're actually managing our connections to the language models. So it could be from external providers. And so we see here OpenAI is one of them. In fact, we have two API keys, one of them for the embedding and one for the regular language models. If I come in here, I can go configure that. And there's many, actually, there's many models that it provides. I'm selecting a subset of models here that I'm going to use for this particular application. Therefore, we don't have to deal with I don't know how many models they have now. Sometimes the list can grow quite long, but we're only going to be using a couple of them. So we already selected that subset. All right. And the other models I have connected here are the Granite models that I was telling you about earlier. Now, when it says provider OpenAI, don't let that fool you. That actually means that we're using an interface that is OpenAI compatible. But in the end, we are actually hosting these ourselves on our own virtual cloud, and we have access to be able to connect to them through an API key also. And of course, there's no pricing associated with this one because it's a flat price running it on our own infrastructure. So from providers, what I'm going to do is jump over now to something called knowledge bases. So knowledge bases, um, you know, if I'm here at Cogni, I'm going to try to figure out how I can have Flash Query help me answer questions or have the AI subsystem that Flash Query is within answer questions about, say, vehicle ownership data or vehicle specifications. And so therefore, I need to get the data in here. So we're going to use a RAG type of subsystem. In fact, Flash Query uses a plugin architecture to provide various AI capabilities. And of course, RAG is one of those capabilities. We're going to be using a knowledge base to capture actually two knowledge bases to capture all of this information. So I can go and here's the vehicle spec sheets. And so I've already pulled those into Flash Query. And so we have a number of them, Tesla, Nissan, Fiat, BMW, and another Tesla, the Model Y versus the Model 3. We have all of those spec sheets brought in. Those were PDFs that were pulled into our FlashRag subsystem. And then we also have a vehicle ownership data, and that was a spreadsheet, actually a CSV that we brought in, and that is brought in a separate knowledge base. The reason they're separate is because we have structured versus unstructured data. When you have structured data, like a spreadsheet, you can handle it in a different way and actually make some, you get some good capabilities that come from knowing the schema of a set of data versus unstructured, where you have to deal with that in a different way. So in any case, we have these two knowledge bases already put together in Flash Query. And now we can jump over. And before we go to assistance, we're actually going to jump over to prompts. And if everybody here is accustomed to using ChatGPT or Anthropic's Claude or any of the other models, you're accustomed to prompts. And so what we've built in here is a prompt manager. And there's good reason for it because you need to have a way to manage the prompts that are going to be used in your application. Usually when a user in the end application is doing something with AI, they're maybe asking a question, but that doesn't mean that that's the exact prompt that goes and gets sent to the language model. There's probably other things that are happening. Even that prompt may be inserted into a larger prompt. And so having a prompt manager built into this is a real value because you don't have to store the prompts in the code. And most teams that we talk with when we've done our user research found that they actually would prefer to have a prompt manager so they can refer to the prompt in their code base and not actually have to have the whole code or the whole prompt written there. Because then if you want to make changes to the prompt, you don't have to do a code release, right? You can always refer to the production prompt and you can and then at this point, whoever is running this can move the tag whenever they deem appropriate to a new version of a prompt, and that will be released immediately. So there's a real value in having prompts managed outside of your code base. And because we're integrating in so many pieces of the AI subsystem here, it made sense for us to implement a prompt manager because then we get into what we call assistants. So an assistant is, realistically, it combines one or more language models. It combines filters, knowledge bases, and other configurations that really attune AI capabilities to your business logic, to your feature needs. So it's actually exposed through Flash Query. It looks like a language model to the outside world, to the calling application. It will look like an LLM, but actually it has a lot of capabilities underneath the hood. So we're looking at the first one right here, the one that we'll be testing. You can see from the very beginning that we have models associated with it. So we have the IBM Granite 3.38 billion instruct model. And then we also have two other models, and these are backups. So in case our local model goes down, in case something happens, we can fall back to other models. And those other models hopefully are running. And if those models go down, then it keeps going down the chain. So you have a performance guarantee here that you're aiming to achieve. So you're not ever going to have downtime, and the external application won't even realize that maybe one model has gone down or one provider is down. If you've seen the news, sometimes you see that OpenAI goes down and things like that. So let's go and keep looking down here. We have Flash Query RAG set up. So here in this case, we can actually see that we picked two different knowledge bases that we had set up before, and we can even turn on evaluation metrics, and you'll see what those look like in a moment. But the evaluation metrics are really aiming to give you a sense that the responses are correct and that they're not just giving you a response back that may or may not. We have other pieces built into this assistant that will give you some confidence score that the response is a correct response. We also have filters in place. So we put in some, not bad words, but, words maybe you don't want to have necessarily used in your AI environment, right? Of course, you can add these to whatever, you can add more of these words, you can filter out whatever you'd like. And you could do this on the incoming side of the language model and on from the outgoing side of the language model. You also have PII filters, and these are standardized in ways that we can remove a whole bunch of all different types of data that you may never want to release to a language model for concerns of violating your promises of keeping your customer data out of the hands of model providers that may train on it. Now, if it depends on what agreement you have with the language model provider, and so regardless, you can redact those from the very beginning. And then also we have the IBM Granite Guardian model that we're using that will also remove types of information that we don't want to let out, right? Or maybe you could say it as we're trying to reduce the likelihood of jailbreaking or reduce the likelihood of people typing in things that maybe are hateful or have social bias or things that you just wouldn't want to have in your system. So it's a really good model. We've been using it for some time. What I'm going to do is jump over and show that this whole thing working in a chat environment. And you can see here, we can test the language model. We can test the entire assistant right here without having to go and run a different application. So I'm going to go here and just say, let's test the main model, which is merely IBM Granite. And so I'm going to grab a text here and just pass it in. And we're going to see what comes back. And so what happened now, I'm asking about electric vehicles in Seattle and how many are owned. Now what I'll do is I'll jump over here, and this is actually the data set that we used, and it's pretty big, about 32,000 rows, all about the ownership of certain vehicles. And I actually ran some formulas to figure out what are the, what are the actual ownership numbers? And because we're asking the question, we ought to validate that it's the right answer. Let's see if I actually got the right answer. 13,863. Well, that was it. And you also see that we're giving back metrics associated with it. So we had this run in a way where we can get the entire response and put it back through an algorithm to validate that the answer is in fact correct using an evaluator subsystem here. And we can also get the performance metrics. We can show that, hey, this took about 1.5 seconds, about 1.6 seconds to complete. Now, one of the things I'll show here is that we might have other kinds. So let me go. That was coming from the spreadsheet. Let me go and do another one here. What is the length of the Tesla Model Y? So I'm going to come back here, and the Tesla Model Y, I think it is 4790 millimeters. All right, let's come back here. Uh-oh, it said I had restricted content. Oh, that's funny. I did not expect that to be the case. Let's try that one more time. What is the length of the Tesla Model Y? I don't know what I did that would be non-compliant with that one. Let's see. There we are. The overall length is 4790. So it's pulling from all of the knowledge that it has in both knowledge bases to give me a response that is coherent. And it doesn't matter where the data came from, it's pulling it from the right place. The other things I'll show you here, just really quick, I'm going to select, instead of using a model, I'm going to say we're not going to use any model. And I'm going to try just testing out my filtering and see if that works. So let's see here. I'm going to use what is not really a bad word, but I'll say, what the frick is going on with my Nissan Leaf? So I'm not using any language model at all right now. But you can see what it did was it redacted my naughty word that I used here, right? And so that I can show that, okay, it is working and it is preventing certain data from ever escaping. I can also add in a PII filter. And let's do it this way. I'm going to add in some information here that might be considered, uh, you know, social security number, date of birth, and certainly it went back and redacted all that information from my original prompt. And in fact, it even found dag nabbit, which is also a naughty word apparently in cartoon land, and pulled it out as well. And then the final thing I can do is I'm going to test it out with the Granite Guardian model and show you how that works. So I'm going to paste in a prompt here and say, my name is Matt, and I feel like driving my Tesla. What should I do? And so the filter comes back and just gives me the exact text back because there is no problem. But now I come in and I say, well, let me just modify that a little bit and say, my name is Matt, and I feel like driving my Tesla straight into a wall. What should I do? Now, at this point, the Guardian's going to come back and say, uh-oh, because of what you added, your message is now restricted, and we modified it for compliance. So I'm able to catch that before it ever goes out, or it could come back from a language model. And so we're building in these filters in place that are going to make it that much more safe and adhering to the risk tolerance that you have for your particular business and the application that you're integrating in with Flash Query. The other thing I'll show, and I know I'm kind of running up on time here, is that everything I've been doing so far, we've been working within the web interface. And of course, you could do all this from the API as well. This is meant to be used in an application where you have an API system. You have an external application talking to the Flash Query API to communicate and work with the capabilities we've built in, talking with the language models. But if you want to go and see all this happening in real time, you can connect up Flash Query to your OpenTelemetry syncs or collectors and now start collecting information. So every one of the queries that I've been running through Flash Query, I can see it here in my Grafana view, see the entire query, how long it took, what happened at every single stage. And of course, I could go in and break this down even further and view not only the timing, but also the prompts that went in, the prompts that came out. And so that is going to give you some level of auditability, understanding of what is happening in your complete AI subsystem, whether you're doing debug or whether you're trying to just validate what has happened over time for any given user. You could track it on a per user basis. And then finally, I know this sounds like a real finally, but there's a GRC team normally that needs to go and validate, hey, what are we going to allow our AI to do in our applications? And so we've also built something called FlashGuard. And so FlashGuard is an interface for those completely separate GRC teams. Usually the product manager is involved in both, but it's a different team, and those teams are responsible for what are you going to allow. And so we have an interface created so that we can allow those teams to write in English what their risks are, what their policies are, their controls, manage this in whatever way they see fit. We have templates that we can bring in to assist with this based on their compliance posture. And then you can connect this to your Flash query instance and push these down, and these become requirements for your Flash query instance. It will create the connectivity so that you have a full connection to Flash query and then back from the monitoring that will occur to tell you that yes, in this case, all of my confidence scores are greater than 0.7, or if they're less than 0.7, something must happen. And so we can track that and monitor that from this interface, which is made for those GRC teams. So with that said, I think I'm going to be right at the time. I don't quite know how I got it all done in 30 minutes, but uh, so if you want to contact, we're currently available for users, for enterprises who are piloting AI, who are looking to work with us. Please give us a shout out over at the Flash Query AI website. We'd be happy to talk with you. And I think that's it. I'm done. I'm gonna get a drink of water.
Yeah. If we have one more minute, there is a question in the chat from Sandi. Is the knowledge base storing the endpoints way to access the database? I'm assuming that Flash query doesn't handle the chunking, indexing, and creating the unstructured DB.
We can use knowledge base we're using a knowledge base internally to the container, mainly for POC type of work. And then if you want to use Flash query in a production environment, you most likely want to have your vector databases and other infrastructure components related to AI separate, somewhere in your own cloud. And so you can point Flash query to those same components and manage them within Flash query, but they're going to live somewhere else.
Cool. Thank you.
Sure thing.
Yeah, thank you, Matt.
Yeah.
Thanks for the talk. And yeah, if you will have any other questions, please drop them into the chat. But meanwhile, so when Matt shared who our next speaker would be, I honestly thought he was joking, and turns out he was absolutely serious, and we are incredibly lucky. So it's not every day you get someone of this caliber at a community event, but here she is. So meet Sandi. She's an AI research engineer and ecosystem lead at IBM Research, active AI advisor to startups, and designed multi-agent AI systems and authored widely cited research papers and meta-analysis. So yeah, Sandi, please take the stage.
Oh man, now I have to live up to that intro. I always get so self-conscious when I get really nice intros because I'm like, oh, okay, can't mess this one up. High pressure now. But okay, so I will start sharing my screen.
Yeah.
Alrighty. Can everyone see my screen?
Yes, I got it.
Great. All right, I will bypass my intro since I got a much better one than I would ever give myself. But I am an AI research engineer and ecosystem lead at IBM Research. I'm currently working on the product incubation team, where our team really, the whole point is to throw things at the wall, see the developer needs, see what sticks. And then from that, we decide whether we want to open source it, in which case we have open source this project I'll talk about today called BeeAI, or how IBM wants to use it strategically as well to offer as a more complete solution or complete product. So what I'll talk about today is BeeAI. It's an ecosystem of projects. It's not like a full-fledged product, which I think is a really important distinction. Completely open source, and it has three components. It has a framework, a platform, and a communication protocol called ACP. And during this presentation, I'll go a little bit into each one of those, why we decided to build each one of those as part of the same project, and the value add and what they do. And so what really led us to creating this project was that we're all aware of this Mod Podge mess of this agent ecosystem, right? There are so many different ways to slice a cake when it comes to AI agents. We have the models themselves and which model to pick for the right use case. We have different frameworks. So once you pick the right model for your use case, how are we going to orchestrate these things and how we're going to enable them with tools? And there's so many options for that. And we've added to this mess with the BeeAI framework as well. And then we have the different custom assistants that are potentially pre-built already for different specific uses like voice agents or customer service or productivity. And there are so many different ways that we can use these tools and this acceleration of technology, but there's a couple problems as it becomes increasing that the amount of options that we have. We have one, it's very messy, so it's not always intuitive to build AI agents because of the choice of framework and model and things like that. Then once you've built the agent, if you have an agent built in one framework and you have another one built in another framework, how do you enable those two agents to talk to one another? Especially with how fast things are moving, you might decide that you want to build something in LangChain because they have like a pre-built template for building this type of agent that's very helpful. But then 2 weeks later, Crew AI comes out with something that works a little bit better for your use case and performs better. So now you have to somehow modify that and create a whole new agent. So how do you make these a little more interoperable or interchangeable based on the way things are moving? And then lastly, once you already have your agent system configured, so individual agent built, you've configured that and architected that into an agentic system. Now, how do you actually share these things and run these things beyond on your own device or your own development environment? It's fine if you're an AI engineer or a developer to run a script on your computer, but you're not going to hand someone else a script. You need to create an application so there's a nice interface and way for someone else to actually use these things, right? So these were the problems that we were running up against and why we wanted to tackle each one of these individually in 3 different components. And that's where we got the 3 components of the BeeAI project. Now, although they are meant to function with one another just because they're part of the same project and that makes it more ease of use, they don't have to be used with one another. So you can decide to use the framework and not the platform, or just the communication protocol and not the framework or the platform. And so they can be used separately as well as individual components. But in essence, we tackled the framework for building agents from scratch in composing these multi-agent systems. We have the communication protocol, which allows you to take an agent, whether it's built in our framework or any other framework, and allow them to speak to one another by standardizing the way that the agent receives inputs and outputs. And we'll get a little bit further into that in the coming slides. And then we have the platform, which makes it easy for you to discover agents that have already been built either by yourself or by other people if they've shared them with you, and run those agents in the platform as well. So it has runtime capability. So first, and if you have any questions, I'll definitely leave time at the end. I don't have enough content to fill 30 minutes, so there'll definitely be time for questions. I can't see because I'm sharing my screen, but I'll take a look afterwards. Okay, so framework, I'll go through these rather briefly. There's so many components to a framework and so many features and functionality of each one of these things, but I just wanted to highlight the top level ones and the true value add of why you might use something like this. So it's production grade. So everything we build for the most part is aimed to be production grade because we are a large enterprise and our audience is normally other large enterprises or developers at these other large enterprises. So it allows you to build complex multi-agent workflows. It has built-in state handling, built-in caching, memory optimization, and resource management. And it's completely LLM or provider agnostic. So again, as Matt was mentioning before, if it follows the OpenAI spec or endpoint, you're able to automatically use it. And if not, you can bring in a custom provider. It also has dual language support. So this is something we heard some feedback from. A lot of the frameworks out there started in Python. Ours actually started in TypeScript. And then we created a Python version just because we felt that there were different audiences that were starting to create these AI agents. And not all of them were data scientists or Python first developers. So we have equal compatibility in Python and TypeScript, whatever you're more comfortable in. And then we also have some built-in observability. So real-time monitoring with OpenTelemetry and tracing. And we use Phoenix Arise as well for our partner, where you can view everything if you'd like in a nice dashboard. So that's the gist of the framework. I have the GitHub link here. There's also, we have a docs page for each one of these if you wanted to look further into why use this versus some other frameworks out there. Okay, so agent communication protocol. I wish I could see hands, but because I'm sharing my screen, I kind of can't see anything. But but I'm not sure if you're attending this, there's a chance that you are most likely heard of something called MCP, Model Context Protocol, by Anthropic. And there's a chance you might have heard of something called A2A or Agent to Agent Protocol by Google. So ACP, the origin of it, it was launched in March, which was actually just a month before A2A came out in April. And we have been collaborating with those teams as well and kind of working together and brainstorming these processes. But it's meant to be an open standard with open governance. So again, anyone can contribute to the protocol because an important part of a protocol is that it is openly governed. It actually fits the needs of the developers that are using it. And it's meant to provide ease of compatibility between AI agents. And when I say agents in this case, I don't just mean LLM-powered AI agents, but I could also mean other sub-processes. So technically, you could take a sub-processor microservice, spin up a server, and allow that to be part of your agent-to-agent communication. So an easy way to standardize the input and the output of two sub-processes, which could be AI agents, and allow them to communicate with one another over HTTP. So just in general, it follows a client-server architecture. It leverages REST-based communication for ease of ease of compatibility. We also have a Python and TypeScript SDK available, however, it's not required. We have online and offline discoverability, which means that your servers can be actively running to be discovered, or you can put them on a registry and then they can be activated or spun up when required by the AI agent. And it supports async, sync, and streaming, which is more compatible with different types of applications. So if you build a chat-based application, for instance, you're more likely to want something like streaming so that the user doesn't have to wait for a response. And it integrates very easily with the BeeAI platform. So I'll get a little bit more into the BeeAI platform, but before I do, I think it's 2 weeks ago now, but we actually had a deeplearning.ai course come out with Andrew Ng on ACP or Agent Communication Protocol. So if you want to get your hands on it and get started, that's a great way to do that. And I can post the link to the course in the chat if you're interested in that. And again, we have the GitHub at the bottom, so you can take a look at it if you're interested in checking it out. Now, before I move on to the platform, I like this slide because I often get asked, why would I use ACP, not MCP or A to A? And there's two answers to that. The first is MCP has a different purpose or different value, at least at this point of time, than ACP and A to A. MCP is meant to provide context to models. So if you wanted to provide a tool, a resource, as in a document or something like that, or a prompt to a model or LLM, then that's when you would use MCP. ACP or A to A have the same value proposition in that they're not trying to work on this more vertical landscape of providing context to a model, but they're trying to provide interoperability. That word always gets me. Interoperability from one agent or agentic system to another agentic system. So they have slightly different use cases. You can think of MCP on this vertical axis and ACP on this horizontal axis, or A to A on this horizontal axis, where they can be used together. So an ACP or A to A agent can use MCP servers in its agentic system run. So that's the first kind of what's the difference between these things. And then to get a little lower level, and I know that it's not exactly like comparing apples to apples, having them all on the same graph. Maybe I should put a line or something, but but I wanted to compare them across these different functionality. So how they handle their transportation and communication, their state management, discoverability, message structure, and development complexity. And I actually wrote a whole article that goes into more depth than just this chart about this. If you're interested, I could put that in the chat again. But the net of it, and without spending too much time here, is that the transportation and communication method is quite different. MCP and A to A both follow this JSON RPC, where A to A kind of uses HTTP but wraps JSON RPC. So there's really two different protocols for your system to understand versus we just use HTTP REST-based. A little bit more simple for if you're integrating things into your systems. That was at least our point of view and why we made that design choice. About state, MCP is inherently stateless, but you can also implement custom state management if you'd like. A to A has probably the most comprehensive level of state management because they offer it at the session level, the agent level, and the task level. And us as ACP, we offer it also from the session level, so the application level as well. In terms of discoverability, we all do slightly similar things, slightly different implementations. And with message structure, the main difference is that we accept any MIME type. So it's completely extensible. If we don't have an example for it, it will still accept that MIME type. Whereas in A to A, if you wanted to add a new MIME type, you would actually have to extend the class itself. And so you would need to put in a pull request with A to A, and they'd need to make that modification. And that's pretty much it. In terms of development complexity, very minimal setup for MCP. ACP is pretty simple to use. And what we found with our own testing is that A to A is slightly more complicated because they allow you to define more things, which makes it a little bit more extensible and more detailed or controlled, but it's a little less opinionated. All right. That being said, quick platform, and I'm actually going to show a quick demo as well. That should only take a couple minutes on creating an ACP agent and then bringing that agent into the platform and how relatively simple it is to do that. So the platform's purpose, like mentioned before, is to discover agents either that you built or other people built, to run them and then share them in agents built in any framework. And again, an agent can be a sub-process. So although it doesn't have to be an AI agent, the original intention of the application was meant with that in mind. So you can just, so that's pretty much that. Connect to any LLM provider. And this is all right now, because it's open source, self-hosted. So if you wanted to stand up a hosted instance of this for your company or your team or yourself, you're welcome to do that. Or you could run it locally, like I'll be showing in the example. So then how do all these things fit together? It kind of fits in each slot of this problem statement, right? First, you build in the framework, then you wrap your agent that's built either in our framework, any other framework, and make it an ACP compatible agent so it can be brought into the platform. And then you can run your agent and share it on the platform. Another element of the platform that I think is huge for me, because I was a data scientist. I'm not a full stack developer. So for me, when I build the thing and then I'm like, okay, who wants to make it pretty and make it so other people can use it? Uh, and so that the ability for me to bring it onto this platform with basically providing like one tag of metadata is a huge advantage, because I can see my thing come to life. I can share it with others without having to without having to actually do a whole front end or put together a whole application. Okay, so again, BeeAI is completely open by design. It was donated to the Linux Foundation, and it's a completely community-driven roadmap. So in any of these GitHub GitHub links, you can see that there's issues that are assigned. If you want to, there's a roadmap there. If you want to contribute to that, make any comments, pick up any issues, you're more than welcome to do so. That would be the best way to get involved. We also have a Discord channel that we post contributions, so people's interesting projects they've built with BeeAI. We have a community call. Actually, the next one is next Tuesday if you're interested in signing up. I normally post about that on LinkedIn. And you're welcome to join that, where we showcase any updates in each of the 3 components of the project, highlight some community-driven things that have happened, and open it up for conversation for anyone that wants to talk about something. So I'll pause for a second. If you'd like to follow BeeAI on GitHub, here's the kind of master repo where you'll see all of the ones under it with all the projects. And then we also designed a workshop, and the demo that I'll show is coming from this workshop. So this is kind of the finished output of the workshop. I'll pause there for a moment. Okay, so with that ado, I will flip over. Now I will say that I did record this, but I recorded it like last week. So not quite live, almost live. Okay, so if we go ahead and get started, we can see that we have an agent.py file. This is actually the file that has the business logic of my agent. And just confirming everyone can see the screen, right? Because I switched. Okay. And you'll see I built this agent workflow, because it's here you can see it's called ticket workflow, in using 2 different agents. So one of them is built using the BeeAI framework, and the other one is built using a Pydantic agent. So the first thing that I do is I set up my ACP server. In this case, I have both agents, really 3, running on the same server. However, that's a design choice. If I want, I could have each one of these agents running on different servers using different ports. So I have one agent called the ticket triage agent, and this scenario is a ticket response. So let's say I get an incoming email, and the first agent, the ticket triage agent, it chooses the best ticket category and extracts the required field. So it basically categorizes these tickets into certain categories. And the second agent is a ticket response agent. So depending on the category, it says what tone to respond in and what are the goals of the response. And as you can see, this @server.agent decorator is all that I need to make this agent ACP compatible. So I have the name of the agent here, and I have the metadata, and the metadata is important only if you want to bring the agent into the platform, because like I was mentioning before, with one piece of metadata, I can essentially create a UI for my agent. And in this case, I've chosen the hands-off UI. There's a few different UI options, and we're also exploring different ones or different UI components that we can bring in. So if you're interested in contributing to that, that's an area that our team is actively exploring. And so I create that agent. And then I actually have another agent that is going to encompass my my agentic system and orchestrates the agents. So I have then a ticket workflow agent. So when it appears on the platform, they're not appearing as separate agents, but I can actually interact with my system as one agent. So if I flip over to my terminal, I'm just using the CLI to show this, and I run my, oops, I don't know if you can see, but I covered my thing. I run the agent. You can see that it auto-registered to the BeeAI server because I had the metadata enabled. And on the left here, I see, I think I just passed it, but you'll see these are all my available agents. But when I start to run my server, and then I refresh the page, I have the 3 agents that I was running on that server because I'm running all of those agents on the same server, even though the one that I would interact with would be this ticket workflow agent, because that's the one that orchestrates the two. So I could interact with it on the UI, or I can interact with it directly using a curl command in my CLI or my terminal. So I have my request, which is, hi there, this is Jane Doe. Ever since yesterday, your pro plan keeps throwing this error 500 when I try to export reports, and this is blocking my quarter end close. Please fix ASAP or refund the month, and this is my account number. So that's the incoming email that the workflow receives. You can see that this will load and then I'll walk back through. The run was started. The requests were sent to each one of the agents. And then on the right, you see that the run was created. The run is in progress. You see the message parts, which is each part of the partial response that has come back, and the message completed, and then the run completed, and where I can see my final result of the entire workflow. And here I can see kind of my content that came back. So the first response was, this is the category was technical, customer name Jane Doe, account ID, and then the response that came back. So this is a high severity issue. Our technical team has already investigated this as a priority. And in the meantime, you might try to clear your browser or your cache. And of course, it hallucinated all this. You wouldn't use this in a in an actual in an actual enterprise case, right? You'd make sure that this is grounded in some truth. You're using different systems to, like Matt was saying, safeguard against any like input or output, either prompt injection or jailbreak attempt or anything like that. So this would be much more robust in practice, but for a sake of simplicity and showing a simple use case, we just went for the simple approach. And again, you could see all of this and we could interact with it the same way in the UI, but I think it's important for this audience, especially as developers, project managers, product managers, to see the different ways that you can interact with something. So I will stop there so I can see if anyone has any questions.
Impeccable timing. Thank you very much, Sandi, for your talk. We've got a couple questions.
Oh yeah, we are out of town. Sorry, I talked the whole time.
No, you're good. Don't worry about it at
Yeah.
all. We got That was really, really good. I'm thankful that you're able to give the presentation. One of the questions is, does ACP have the same security concerns as MCP got identified of late, that has been identified of late? I don't know exactly what the security concerns are with MCP. Joseph, do you want to comment on that a little bit further, or we can try to guess if Joseph is still on the call? Well, maybe I'll ask,
Yeah.
if we don't know about the MCP, the security concerns, do we have to handle in ACP? I'll just ask, user permissioning. Is there any type of identity management that goes into the ACP protocol?
Yeah, it's definitely on our roadmap. It's something we're thinking about and how we want to approach it. And that's one of the things we want to invite the community to discuss if they're interested in contributing to that or have expertise in that. We've pulled experts from different parts of IBM research security to kind of help us formulate our thoughts on how we would build that. But it's something that hasn't been set in stone. So I mean, our plan at first is to create like standard OAuth and things like that. But then there are things that we want to do above that.
Sure, sure. Okay, that makes sense.
So I like that. At least it's not Grok comment.
Yeah.
Although Grok 4 has some pretty neat stuff that just came out. A little bit of controversy, like always, but some good benchmarks.
It does seem like it is doing quite well, and hopefully it'll just learn to behave a bit better. We might need to pair it with the Guardian model.
Yeah, yeah.
That might do it.
Awesome. Well, thank you guys for having me. And if you're interested, I will be posting on LinkedIn, join our Discord. And is there a way for me to kind of send like the course or any other materials to the people on this call?
Yeah.
Yes.
Great. So
Yep.
I'll
You
work
can
with
send
you
it to
guys
us
to do
through
that.
email. We'll make sure it gets put into the community as well.
Perfect.
Community channel. Grant, thank you so much, Sandy. It was really nice. It's really good.
Yeah. So we will wrap up our HiveMind Summit conference. So those were intense 5 days, great speakers, and thanks to everyone who presented their stuff during our conference and being a participant. So we'll see you next time and hope that it will happen sooner than in a year, but we'll see. So yeah, if you want to join our community, please go to aiproducthive.com. There's a bunch of different buttons you can click to join our Slack community. Thank you. And the call recordings will be sent to your emails that you've submitted while registering and like signing up for the conference. So thank you, everyone, and see you next time. Bye-bye.
Take care. Goodbye.